All right, let's start part 2, everybody. So, 1 through 5 ended part 1. All right, so let's tackle 6. Again, it says determine the exact value. So, we got to really understand what that means. Of cosine of 105. So, anybody could type in cosine of 105 and get some decimal number. That is not what they're asking you to do. Use the angle sum or difference formulas. This is where you got to use the sum of two numbers or the difference of two numbers to create 105. But you need 30, 45, or 60 reference angles. So as I look at these, I'm like, wait a minute. If I add those together, that gives me 105. So what I'm going to do is I'm going to go cosine of 45 plus 60. $1 million question. What if a student wrote 60 plus 45? No problem. So here's my cosine of u plus v. So basically, we need to now use the formula that matches this, which cosine of u plus v is right here. So if we take that, let me slide this up just a little bit so you guys can see it. My cosine of u plus v formula is right here. So I'm going to get cosine of u, 45, cosine of v, 60, minus sine of u, 45, sine of v, 60. Now, good news. I've already got my 60-degree reference angle right up here. Is that on the camera? Yes, it is. So I'm going to use this triangle for this and this. So, cosine of 60, adjacent over hypotenuse. We'll get to the 45 in a minute. Minus, we'll get to the 45 in a minute. What is sine of 60? Well, it's opposite over hypotenuse. We just figured that out over here. So now we need a 45-degree spin. Well, that's going to be here. There's my 45. That's got to be 1, 1, square root of 2. So cosine would be adjacent over hypotenuse. Sine would be opposite over hypotenuse. And now it's a mishmash of algebra. So here we go. This right here is 1 over 2 square root of 2. Right here, minus the square root of 3 over 2 square root of 2. Now, a lot of people get worried about getting the radical out now. Don't do that because we've got common denominators. That means we can add the stuff in the top just to simplify it, even though they're not like terms. Now we should attack this. Remember, we're not worried about that because it doesn't have a square root on it. So all I want to do is attack the square root of 2. So I distribute. So I get the square root of 2 minus the square root of 6 all over. Now, square root of 2 times the square root of 2 is 2. Times 2 is 4. And you can't reduce that. So we are done. All right, here comes a little bit of a doozy. In triangle ABC, where angle B is 100. Uh-oh. 100. That would have been bad. Angle C is 39. Side A is 25. Remember, side A is opposite angle A. Side B is opposite side B. Side C is opposite little c. Excuse me, side C is little, but it's opposite big C. Remember, the angles are always big, the sides are always small. And with that in mind, solve the triangle completely. Well, the easiest thing to do right now is find angle A. 100 plus 39, if we just subtract that from 180, we'd get 41. So that was easy. There's people in geometry class doing that stuff, and that's not hard. Now that we have, check this out, angle A and side A, we could find using the law of sine. Remember, always try to use the law of sine before you use the law of cosine. This is way easier. I'm going to use sine of A over side A, and now I can find angle side B or side C first. It doesn't matter, but I'm just going to go with this one. So I'm going to go sine of angle B all over side B. Get out my handy dandy calculator. And a huge thing you got to remember to do right now is make sure your calculator is in degree mode, and you can see that it is. So I can clear that out. And here we go. Sine of 41 degrees, 0.656. Put that right there. And then sine of 100, 0.984. And remember, now we're going to cross multiply. So I'm going to take that last answer, 0.984, times 24.6. So I get 24.62, but we'll just call it 0.6, equals, and if we cross multiply that way, we get 0.656b. Divide by 0.656, gone. Divide by 0.656, 0.656, enter, 37.5, close enough. So B is 37.5. All right, so 37.5. Now, I have had students get to this place, and they decide to go a squared plus b squared equals c squared because they think of this as the hypotenuse. You cannot use the Pythagorean theorem if this isn't 90 degrees. So, how do we find c? Well, again, we could use the law of cosine, but law of sine is way easier, so we're going to use that again. So here we go. Now, see if I'm on the screen. I am. I'm going to use sine of angle C over side C. And I'm going to go ahead and use this stuff because I already know it, and it's right above it. Sine of 100. Now I know B is 37.5. And here we go. So I know sine of 100 is 0.984. So I'm going to cross multiply. 0.984C equals, now I got to find sine of 39, hit enter, multiply that by 37.5, 23.6 we'll call it. And then we'll divide that by 0.984. Uh-oh. Okay. That just looked funny to me. So C is 23.98, which if we wanted to say approximately 24. So 24. All right. Which makes sense because these two are so close to each other because 39 and 41, I mean, they're almost the same, so these sides should be almost the same. All right. Well, how do we do this area business? Well, again, we got these formulas right here, and these are for all triangles, including right triangles, but this doesn't have one. So I'm going to try to show you the formula and not confuse you here. All right, can we get that all on there? All right. So as you can see, we got all sides and all angles, which means we can use any one of these. So I'm just going to use 1/2 BC sine of angle A because it's the first one listed. Now that I've got my formula taken care of, 1/2 B 37.5 times C, which is 24, times sine of angle A, which is 41 degrees. And now it's just a calculator special. The only thing I get worried about is people distribute this 1/2 through everything. This is just this times this times this times this. And remember, multiplication is commutative. You can do it in any order. So I'm going to find sine of 41 first, multiply that by 24, multiply that by 37.5, multiply that by 0.5, which is 1/2, and I get approximately 295.22 square units because, oh, it's inches, so I don't need to use square units. I'm going to use square inches. All right, there's that. Okay, cruising. Number 8. Again, there's so many formulas in this unit that they do you a solid and they direct your attention to where to go. Use double angle identities. Well, here they are. Double angle formulas, identities. So, simplify. That's all you got to do. You're not solving. You're not finding exact values. You're just simplifying. So we just go on the hunt. Where do we see that? Well, we see that right here. But now this is asking us to think from here to there. So we'd simply have to double the angle and turn it into cosine. So this equals cosine of 6 theta. That's all you do. Looks hard. It's not. Where's this looking thing? Well, that looking thing is right here. So we match this with this, and then we think, oh, we have to go that way. So that would just simplify into cosine, double the angle. Well, the angle's 2x, so it's going to be 4x. That's it, you guys. So don't be intimidated by those. And then a blast from the past. Write an equation for the line. Y equals mx plus b. Got to find both. So here's my x1, y1. Here's my x2, y2. We got to find the slope and the y-intercept. Well, y2 minus y1 over x2 minus x1 is negative 2 over 4, which is negative 1/2. It's another formula that maybe I need to give you, but I think that should be in your memory somewhere. There's your slope formula. So now that I found the slope, I am not done. I still need to find the y-intercept. How? I can pick this point or this point to plug in here. I'm going to pick this one. So y equals negative 1/2 x plus b. That's just 5 equals negative 2 plus b. Add 2 to both sides, and I get b is 7. Put that right there, and my answer is y equals negative 1/2 x plus 7. There it is. Number 10. When I showed this to you guys, I gave you a little rhythm. Factor, 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 factor. In other words, you can't just start canceling these until they are multiples of each other. So this is a trinomial that we're going to factor. 2 factors of negative 28, that up to 3. 7, negative 4. How do you factor this? Take a 2 out. X plus 3 times, take a 2 out. 2, x minus 7. This one right here, difference of 2 squares, x minus 7, x plus 7. Now everything's factors of each other, so we can go on the hack fest. These can go bye-bye. These can go bye-bye. This 2 and that 2, bye-bye. What are we left with? X minus 4 all over x plus 3. You could leave it there. You could put parentheses around it. Just don't cross those x's out. All right. Number 11. If this is my function, evaluate f of x minus 3, which means plug it in there. So I get 2 times x minus 3 squared plus 7. Well, we better figure out what that is by multiplying it by itself. Don't just square this and think you're on the right path. You ain't. So x squared outside inside minus 6x plus 9 times 2. 2x squared minus, whoopsie, 12x, that easy to make a mistake, plus 18 plus 7. Don't forget that little bugger. So my answer is 2x squared minus 12x plus 25 for that problem right there. Next one. This is just plug her in. But be careful. It's 2 times negative 2 squared plus 7. PEMDAS. 2 times 4 plus 7. 8 plus 7. 15. Let me pause this for a second.